All right, we're starting chapter 15, the radical chapter. And so we are going to be able to simplify radicals and simplify rational exponents. So the square root of 36 is just the number times itself that gives you 36, which would just be 6. And we're just going to assume positive values right now. On this one, we're going to take the exponent of 28 and divide it by 4, which is going to give us 7. So don't forget that there is a negative sign out in front, and so this would be negative x to the 7th power. Raising something to the 1/2 is the same as taking the square root of that number in parentheses, which then I can apply the square root of 1, the square root of 25, which would simplify to 1/25. Now, when I'm raising this parentheses in raising it to the 4/3 power, what I'm going to do is I'm going to take the cube root, the denominator is always the root, of 8x to the 3rd over 27, and once I take the cube root of that, I am going to raise that to the 4th power. So the cube root of 8 is 2, the cube root of x cubed is x, and the cube root of 27 is 3. And now I'm going to raise that to the 4th power, which means I need to raise everything to the 4th power. So 2 to the 4th, x to the 4th, and 3 to the 4th. And that simplifies to 16x to the 4th over 81. Now you can take odd roots of negative numbers. So the cube root of negative 125 is going to be negative 5. The cube root of a to the 15th is going to be a to the 5th. And the cube root of b cubed is going to be b. Now, when I have a big group in parentheses, I always check to see if there's something that I can simplify before I'm applying that radical. And so right off the bat, I see an x to the 1/3 power in the numerator and an x to the 1/3 power in the denominator. So that's going to eliminate because that makes 1. And so now I'm going to take 4 squared and y to the 7th, and I'm going to raise that to the 1/2 power. And so I am going to, just like I did in the last one, in number 46, I have to distribute this exponent. So this becomes 4 to the 2nd raised to the 1/2, and this becomes y to the 7th raised to the 1/2. And so then I'm multiplying power times power. And so 2 times 1/2 just becomes 1, and y, 7 times 1/2 becomes 7. Oh, excuse me, that becomes 7/2, and that would be my answer. Now, when I'm doing these operations here, I am going to FOIL, and so the square root of 11 times the square root of 11 is the square root of 121. This gives me negative 2 radical 11. This gives me positive 2 radical 11, and those are going to eliminate each other. And this gives me negative 4. And so now I simplify. The square root of 121 is 11. Negative 2 radical 11 and positive 2 radical 11 cancel each other out, and then I'm going to subtract 4. And so my final answer is 7. When I have bigger radicals, I just have to remember the outside numbers multiply each other, the inside numbers multiply each other, and if I can simplify like terms, then I do that. So 5 times 7 is 35. Radical 3 times radical 3 is radical 9, and then I get 40 radical 3, and then I get 63 radical 3, and then I get 72. And now I have to clean it up a little bit. So this is 3 times 35, which comes out to be 105. These two can be added together because they are like terms. So 40 plus 63 is 103 radical 3, and then I have 72. And then last but not least, I am going to collect 105 and 72, which makes 177 plus 103 radical 3. Now, in order to add or subtract radicals, you have to have the same radicand. So I'm going to come over here because this radicand is 27, and that is not going to be able to be added to 3 radical 3. So I'm going to take 27 and I'm going to break it up as radical 9 times radical 3, which is 3 radical 3. But then I have this 9 that's out in front. So that simplifies to 27 radical 3. That takes care of this term right here. And so now I have to add this to this. So that becomes 3 radical 3. And so my final answer, this is number 51, 27 plus 3 is 30, and then I just keep the radical 3. Now for 52, I can simplify. Square root of 144 is 12. Square root of 100 is 10. And then I have to simplify these radicals so that I can put those together. So if I look at the square root of 12, that is 4 times 3. Let me come over here. So that's square root of 4 is 2, and then I leave 3 in the radical. 48 is 16 times 3, and so that becomes, the square root of 16 is 4 radical 3. And so now I'm going to add 12 plus 10, and that makes 22. And then I'm going to add 2 radical 3 plus 4 radical 3, and that makes 6 radical 3. Now for the next ones, we are going to be rationalizing the denominator. So if you have just a square root, you just simply multiply by that square root over itself. So then I take the square root of 13 times the square root of 5 is the square root of 65. And the square root of 5 times the square root of 5 is the square root of 25. And now I simplify. Square root of 65 over 5. And remember, you cannot take a number that's outside of a radical and go into a radical to try and reduce it. So that's all you can do on that one. Now, cubes are a little bit different because we want to make things in groups of 3. So if I look at 25, that is 5 times 5. And if I look at x squared, that's x times x. And so I have 2 5s and I have 2 x's. But because this is a 3, I need to have 3 5s and 3 x's. So the only thing that I am missing is the cube root of 1 5 and 1 x. And so now what's going to happen is that 7 times the cube root of 5x is the numerator. And then I have the cube root. 5 times 5 times 5 is 125. And x times x times x is x cubed. And now I can simplify that. So the numerator still looks kind of funky because there's nothing I can do with that, and that's it. And then the denominator, the cube root of 125 is 5, and the cube root of x cubed is x. Now for the last one, we have to multiply by the conjugate. And remember, the conjugate is the same terms with the opposite sign in the middle. So we are going to multiply by 7 plus square root of 6 over 7 plus square root of 6. And so I'm just going to distribute on the top. So that gives me 21 plus 3 radical 6. And remember, the reason that I do the conjugate is so that I only have to do the first, 7 times 7, and the last, negative square root of 36. And that can be simplified to 6. So my numerator stays 21 plus 3 radical 6 over 49 minus 6 is 43. And the application problem, we're going to use the Pythagorean theorem, which remember is a squared plus b squared equals c squared. So we have a pole that hits the ground at 6 feet. It is 11 feet from where the bottom of the pole is, and what we're trying to find is this height of the rope. So I'm going to take 6 squared plus 11 squared equals x squared, and that's 36 plus 121 is equal to x squared, and that is going to be 157 is equal to x squared. And so then I'm simply going to take the square root of 157, and it says round to the nearest tenth, which means that I'm going to have 1 decimal place. So when I take the square root of 157, I get 12.5 feet. And then number 57 is simply taking the square root of 848 and approximating it to 3 decimal places, which comes out to be 29.120, because the number after the 0 is a 4, which means the 0 stays the same. And that will finish up the part with radicals and rational exponents, and then we're going to do another video on the imaginary.